Hi, we're Civil Engineering Team 15, and our project was to design a self-driving car test track for Yukon. Autonomous vehicles are a rapidly advancing technology, and Yukon wants to be at the forefront. As new models are developed, they need a place where they can safely and rigorously be tested. Our design team took inspiration from existing test tracks around the country and used our knowledge of modern road design techniques to create a test track that can be used to simulate a wide variety of traffic conditions.
The design team was tasked with providing a roadway plan for the Connected and Automated Vehicle Test Facility in order to assist the Connecticut Transportation Research Center in its exploration of the design and construction of a training facility focused on autonomous vehicles and transportation safety. The facility would need to be capable of supporting the research of third-party entities across the emerging areas of future technologies within this field. Topography was one of the first natural factors that the team needed to consider, specifically in the rural section in supporting the proposed highway. This would become important to the design team pertaining to cut and fill amounts in order to ensure the feasibility of the design, both structurally and financially. The design team accessed CT Echo wetland mapping in order to consider the limits within the project area, located on the Yukon Depot campus off Middle Turnpike. Two areas of concern were identified and considered in the drafting of alternatives. The team understood that the wetland effects could be mitigated. Specific criteria was outlined when looking at site features, including uniquely designed intersections, a variety of lane configurations, lane features such as rotaries, building facades to test driving capabilities in urban areas, signalized stopped and uncontrolled intersections, a section of road capable of accommodating freeway speeds, and a tunnel for making sure that vehicles can function while direct satellite communication is lost.
Leading to the final design, alternatives were created to demonstrate potential other options for the test facility. Our main focus was to optimize the facility for the most possible driving situations while keeping value in mind. Our first design alternative minimized the amount of wetland impact on the southwest portion of the property, but therefore led to minimal amounts of rural testing environments. Our second design alternative incorporated a tunnel for the highway section, but this is an extremely expensive option with limited practical uses. The third alternative design added a covered section to the highway and explored the option of adding aesthetic features such as a small pond. Through cost analysis, it was determined that the most expensive aspect of the project to mitigate was the amount of excavation needed. As the design was being worked on, it was important to manage the amount of cut and fill needed during the construction phase to keep costs within budget. All of the alternatives have a long highway section suitable in length for high speeds, which was a necessary requirement of the project.
Working with feedback from the Connecticut Transportation Institute, our team narrowed down our designs until a final urban and rural section were chosen. The final design incorporates aspects of two alternatives, the urban section of Alternative 2 and the rural section of Alternative 4. This design is one of the more expensive options, making full use of the southwest section of the property and providing many different road scenarios. Two sections of gravel road provide varied surfaces for vehicles to test on, while a roundabout in the urban section will be an open asphalt pad that can be restriped for testing different lane combinations. Vehicles can enter the facility from two locations in the northeast section and access on-site garages and monitoring buildings. The shape of the property was the major limiting factor in our design, forcing us to create two areas joined by a central highway section down the middle. This modular layout allowed our team to experiment with many iterations before reaching our final design. The team hopes that implementing this autonomous vehicle testing facility can expand Yukon's research capabilities in the groundbreaking field of self-driving vehicles.